Hello, everybody, and thank you for coming to my talk. This is 10 years of Ruby-powered citizen science at RubyKaigi Takeout 2021. Thanks for having me. My name is Matt Schaffer. I'm an engineer at Elastic, a volunteer at Safecast, which is what I'm going to be talking about today, and a resident of Yamanashi Prefecture. So you can see me there hanging out by my wood pile. I just wanted to underline Elastic. They're my employer. Safecast, which I'm going to be talking about today, is a volunteer time off activity that I do as part of being at Elastic. Elastic gives me 5 full business days per year. Work on the side is open and welcome. It's a global company, and I get to be a Japanese Shine despite it being a global company, which is pretty nice. Check out our careers page if you're interested in doing similar things. So about Safecast. Safecast is probably best known for this radiation map that you see here. What we've been doing is collecting radiation data and various environmental hazard data for the past 10 years in the wake of the Fukushima disaster. I've talked about Safecast before at RubyKaigi, specifically at the 2017 RubyKaigi. If you want more of a deeper dive into kind of how the project got started and what we do and a lot of the background, go take a look at that presentation. It has a lot more detail. I'm just going to do a very, very brief version of that today. So the quick background. So in the wake of the 2011 Fukushima tsunami and subsequent nuclear disaster, there was a lot of confusion around the state of radiation. Were people safe? Did they need to evacuate? There really wasn't a lot of data available to answer those questions for people. So in response, Safecast was one of the organizations that got started, and they started very simply, just a Geiger counter rather, duct taped to the outside of a truck window and an iPhone to take pictures of it. And it was simple, the idea worked, and it allowed Safecast to start collecting radiation measurements and giving people the data they needed to make important decisions about what they would do in order to keep them and their loved ones safe from the disaster. It got a little bit more technically advanced, as you can imagine, not really scalable to have people duct taping Geiger counters to their windows and taking pictures of them. So things advanced from there. We turned the duct taped Geiger counter into a computer in a weatherproof box, eventually shrank that down into something that could be strapped to the side of a car, recruited over 1,000 volunteers around the country and now around the world to help drive around and collect radiation measurements. You can even see one mounted to the back of a postal service bike there. You can really mount these things to anything, clip them to a bag, clip them to a car, a bike, whatever, and you can collect the radiation measurements from your environment, which is important because people care about specifically where they are and what kind of environmental hazards might impact them where they are. So fast forward 10 years. We've now got about 196 million data points in our database. We get referenced and cited by a number of important organizations. We got some logos up there too. We've got a map, which is now the largest open data set of environmental radiation data. So just sort of ambient radiation data, all Creative Commons, 0 public domain data. We've been doing our YouTube channel. You can see up there, we had our 10th anniversary just recently, which is a big like 24-hour telethon. We speak at various international nuclear conferences, and we do our best to track unfolding events in environmental hazard data, radiation being, of course, the prime one that we work on and getting into air as well. So I want to talk about how it works. I'll do this in 2 parts. First is the devices. There's no Ruby here yet. There maybe could be. We're doing some interesting things with M5 Stack, and I noticed that there's an mruby build for M5 Stack. So if you work on this or know anything about it, definitely get in touch. We would love to have some people working on getting more Ruby into the devices. I think that could be a lot of fun. So we have 3 sort of out in the field workhorse devices right now. The main one being that wildfires Nano on the left there, which is the one that you saw strapped to the car earlier. So this is a weatherproof kit that anyone can build on their own and take around with them. I have my own here that I've taken around the world many times now. Trusty, keeps working, and it provides a lot of the data that we have in our database today. The one you see in the middle is PointCast. This is a radiation sensor that can get bolted to a wall. It needs to get plugged into power. I talked a little bit more detail about PointCast in the 2017 presentation, but basically this was our main fixed point sensor that would continually report back to us. And this was great, but it was a little bit of struggle to get these things installed and powered and Wi-Fi, that sort of thing, which led to the Solarcast, which I'll include here because it's one of our older devices at this point, although it was kind of a prototype. But the idea was, let's do more continual fixed point reporting without having to worry about the power and the Ethernet and all that sort of stuff. It was like a drop it and forget it device that measured both air and radiation. And it was basically the start of our getting into air data. And I've talked about all these in the 2017 presentation. So a couple of new devices as well. So we have the Solarcast Nano, which is a radiation-only version of the Solarcast that I just showed you. And this goes by that drop and forget principle. So it's a little bit like a WildFire Nano in that it collects radiation data and it's weatherproof. It's a little bit like a Solarcast in that it's 3G connected and also solar powered. So you can just drop it anywhere. We've been going around clipping these to fence posts and telephone poles and things like that near nuclear facilities to start getting more continual reporting of radiation data. We also have the WildFire Cast, which is an ESP32 that you can plug into the shield on your WildFire Nano. I have one of those plugged into my WildFire Nano as well. And basically what this does is it takes what would be your WildFire Nano, your trusty mobile sensor, and it turns it into a fixed point sensor. So it can connect to Wi-Fi, it can connect to Bluetooth. You just have to plug it into continual power and it will continually report the data that comes in via the Gaigi Cast shield that you can put on the Arduino FIO there. And then finally, we have the WildFire Zen, which is kind of our next generation for the WildFire Nano. As you can see, it's got an M5 stack right on the front there, GPS, and it's got a radiation sensor on the back, the same way the WildFire Nano has today. The M5 stack is really compelling technology here and basically allows us to get a lot of the things that we would have to solder on to the WildFire Nano all in one package. So the assembly gets a lot simpler too. So looking forward to having that one generally available before too much more time passes. It's an active development as we speak. And finally, the Airnote, which we did in collaboration with Blues Wireless. So this was kind of the final product that started with the Solarcast. So a lot of the challenges that we ran into with the Solarcast got embedded into solutions in this project. And what this is an air sensor that you can drop and forget. It's solar powered. You basically just double stick tape it to a window or a wall, just find some sunny spot for it. And it will continually report PM 2.5 data back to our servers or your servers if you want. It's all public data. So this works using technology from Blues Wireless called the Note Card. You can pick one up for use in any of your own projects. And what it does is it gives you 500 megabytes of data, 10 years. The contract is built in to the card. So you don't have to worry about, data plan contracts, anything like that. It works globally. And it powers the Airnote today so that you don't have to worry about, how to connect it. Like literally you turn it on, stick it to a sunny spot and you're done. And then the data becomes available via our Grafana instance, which is also public. And I have an example here of my own Airnote that's sitting outside measuring PM 2.5 data and temperature and all that fun stuff for me. So it's been really interesting. We're also experimenting with radiation versions of this Airnote platform that could be solar powered and just sort of stick it and forget it, and hopefully get all these IoT sensors out in the world to collect various hazard data using whatever sensor seems most appropriate. Cool. Next, I'll talk about how it works. This is the cloud side. This is where the Ruby comes in. And I talked in some detail about this in my 2017 talk. Obviously, we've been working on it in the last 4 years, so I'll talk a little bit about what's new there as well. So the way the data comes in to the Safecast cloud, basically any of these devices like the Airnote, the WildFire Cast, Solarcast, all those, they produce some kind of data. We normalize that down to JSON. A lot of the newer devices just they report JSON on their own. The older devices like the WildFire Nano don't have the capability to produce JSON blob, so they have a much simpler format than we turn into JSON. That goes into ingest, which is our main kind of ingest collection point application. That is Ruby and then Grape API to handle the HTTP connectivity. That goes into Amazon's simple notification service, SNS, and that fans out to a number of different locations. So it goes into Elasticsearch at Elastic Cloud. It goes into S3 buckets that Safecast owns and controls, and goes into our own RDS instances as well. And then I put your app in question marks at the end here, because if you go to that datasets URL, you'll find a public ARN where you can subscribe anything you want. You could potentially even subscribe an email address, although I don't know if you want that many emails coming into an email box. You can subscribe HTTP, which probably makes a lot more sense. And then basically anytime we get data in to ingest, which includes all this Airnote data, all the RubyKaigi data, all the Solarcast data, all that fun stuff, is going to come into your application as well as just a regular HTTP post. So you can collect this and do what you want with it as well. And then on the other end, we have the API application, which is a Ruby on Rails application. You can go to api.safecast.org. And what this does is it provides a UI and management layer on top of those data sources, and then also allows you to do bulk uploads as well. So the older devices like the RubyKaigi Nano, they don't do continual reporting. So they basically produce a file on an SD card that you can then upload into the Safecast API to get all the data into our servers from there. So what's new? What have we been doing in the last 4 years since the last time I talked about all this? There's been a lot of infrastructure updates. One is that public SNS topic that I talked about that I'm really excited about. If you want to ingest and do whatever you want with this data, you can go for it. We also have public S3 buckets as well if you want to just do reporting on the data that's already there. DigitalOcean and Cloud 66 was where we were deployed back in 2017. We've since moved to AWS and RDS, which has been a boon for scalability and then also testing and reproducing problems as well. It allows us to do things like spin up whole extra stacks really easily in just one place to do testing of migrations and data changes. CI has also seen a lot of improvement. We were originally on Travis. We moved to Semaphore for a little while and then Circle CI, and then we're starting to get into GitHub Actions now that we have access to those as well. Both Circle CI and GitHub Actions are at play right now, and they're both pretty good solutions, and they keep everything running nice and fast, make the deploys a lot simpler, and certainly keep the test suite running and green and happy. We've moved mostly from New Relic to Elastic APM. This has been great because Elastic APM, you don't pay for the number of hosts. New Relic, we were limited to just 5 hosts. With Elastic APM, we can scale out as much as we want, and we just pay for the data storage. And then, of course, since I'm an Elastic employee, we get a nice sponsorship based on that case. So so we can collect all the data that we used to collect via New Relic, but much wider. We can have all of our apps, we can have dev, we can have even people's workstations report into Elastic APM, and it's no problem. A ton of upgrades. I was looking through Git history in preparation for this talk, and we've had Ruby version upgrades, we've had Rails version upgrades, Postgres version upgrades, Elasticsearch upgrades, and just like so many gems. It's amazing the number of Dependabot PRs that you can accumulate on a public project in 4 years. So many little gem updates over that period. And then finally, I just thought I'd call out since 2017, we've also added Windows and Gitpod dev support. It'd be great to do code spaces at some point. We don't have access to it yet, but this has been a boon for making it easier for people to contribute to the project. Back in 2017, there was a bit of a setup hassle that you have to go through, and we've mostly ironed that out. So we've had interns and volunteers and all sorts of collaborators that come in from Windows, or lately, since we use Gitpod, that's been great as well because there's no setup. You just click the Gitpod button and you're pretty much good to go. So people can contribute a lot more easily. A number of new features in the interim as well. One is a better bulk import flow. So when you're doing that upload from your RubyKaigi, we have a new map that you can see in the bottom half there that's been improved since 2017. We also have some new measurements, highest measurement, number of measurements, that sort of thing, all coming here as well. We have better data approval tracking and also auto approval, so we can do a little bit of back and forth on the approval process. If we see something that looks like an errant data point, we can contact the uploader. And then also we have a new auto approval system as well, which has been great and really helped speed up the process of having someone upload something, having a moderator look at it, make sure it looks reasonable, and then getting that up onto map.safecast.org. So now we have a number of rules for the auto approver, and so long as everything is green, we automatically put it right up on the map. So nothing that would stand out as a possible problem. And we can always go back and have a moderator look at it if we decide to afterwards. Reminders for incomplete uploads. We had a lot of cases where people were uploading those data dumps that from the RubyKaigi that we talked about, and then just sort of like not submitting them for approval, or maybe not including like what city it was in or credit information or any of that kind of thing. So we have a new email that goes out on a periodic basis if anyone has anything that they've uploaded that they haven't finished, so that they can go back in and finish it. Cosmic data support is another one that we've added in the last 4 years. This is kind of a fun one. It's a flight from Nagoya to Helsinki that I was on. Originally, we would allow people to upload these, but we wouldn't approve them because you don't want to have, map.safecast.org have like this mix of surface level and cosmic level radiation data. It also looks kind of weird because you get all these flight lines running across the map. So we added support for cosmic data in the database so that we can upload it and view it via the nice fancy map viewer. But we don't sort of end up having a real messy data map, which is supposed to be mostly just surface level drive data at this stage. So this one's also kind of a fun one. If you've ever been on an airplane with a Geiger counter, it's very interesting to see the high CPM and microsieverts rates that you run into when taking an international flight. Just highlighted a data point from 11,000 meters there that I thought was fun. And also device stories, which allows you to view graphs and post comments and also photos of your device. I have an example of my Airnote installation here, which I've had to move around a couple of times to find a nice sunny spot for it. So I've been posting photos of different installation locations as I go, and also just commenting about if I'm having battery trouble or anything like that with the device. So we're hoping that this gives people a little bit more of a connection to the device that they work with. We've also been doing a lot of outreach over the past 10 years. I mentioned the 10th anniversary telethon, which you can take a look at safecast.10. All of our videos are up and available there. We did a little bit with COVID-19 tracking, especially test tracking in the beginning. Haven't seen as much of that lately, especially now that we're into the kind of vaccination stage. We've been more focusing on the air and radiation, which is sort of stuff that we're certainly a lot more adept at measuring and figuring out what we should do about. We've been doing online kids workshops. I highlighted a link there that we did to one that we did just recently, help kids learn about electronics and also radiation and hazards in their environment and that sort of thing. And of course, many news and podcast and video appearances and interviews that you can follow along on our Twitter feed. I want to talk a little bit about how you could help. A big reason that I do these sort of talks is to try to encourage people to come out and help out with the project. And I wanted to get concrete about things that people could help out with. One is those upgrades that I mentioned. The Ruby and Rails ecosystem move very, very fast. And so it's a challenge as a volunteer organization with basically no full-time developers to try to keep up to tabs with all of the new version upgrades. We are fairly recent at when I'm speaking to you right now, but things fall behind as time goes on. It's also an old app that we've been upgrading continually. So you run into cases where what was a deprecation warning is now a deprecation. You've got to kind of rework a little bit of the code. Our test suite is solid. Dev ends are ready, and we can make new development environments very easily now that we're on AWS. PRs for upgrades are very, very welcome. If you have any sort of experience in upgrading Rails applications or Ruby and Grape applications, upgrading the gems, upgrading Rails, upgrading Ruby itself, we would love to have your help on this front. And then upgrading Postgres and Elasticsearch, our data storage layer, has been also one that's been a bit of a challenge. This is a lot of data. I think we're up to about 200 gigabytes or so in Postgres, and I haven't looked at the Elasticsearch side recently. It's all cloud though, which is good. So it makes it easy to make new instances. So if you want to do a test, you can actually take a snapshot of our current database, spin up a new instance, run the test or run the upgrade test, and attach an application to it and kind of see how it runs. So everything's pretty well there and fairly automated so that you can tackle this sort of stuff. I would be delighted to help you try to accomplish some of these tasks, because right now I do a whole lot of it myself, and it's a lot to try to handle. Help with new features would be great too. UI and UX is something that I didn't have on this graph or have on this slide originally, but as I was taking all my screenshots, I realized right now, a lot of our UI around Safecast is really just like hacker design. We haven't really had anyone look at the whole upload flow or the registration flow and try to think how could this be better. It would be amazing to have some more focus and talent in this space, and maybe do some new designs about how we could take what we have today and streamline workflows and organize pages a little bit better. We do pretty well with the code and we do really well with the devices, but trying to make things really easy to use is something that we don't always have good in-house expertise for. Mapping and graphing is another one. Map.safecast.org is great, but it's very radiation centric. We're doing a lot with Grafana in the airspace, but Grafana's built-in mapping support is it's good, but it's basic. It would be amazing to have some people doing Kepler AI work or something along those lines to build better maps for our radiation and what we have in our air data space now as well. Deployment, we're on Beanstalk today, which works pretty well. Kubernetes, Fargate, all this stuff is fun. Could be a little bit more push button, to have something in Slack, for example, build comes into Slack, click a button, and that pushes everything out. We're great to have a little bit more in this space. Data validation is something that we're still trying to figure out. For the RubyKaigi uploads, those go into a moderation queue and we have a moderator look at it. But for the continual reporting, we don't have a great answer for that yet. we're imagining it could be nice to have something kind of blockchain-like, where basically anyone can vouch for like a chunk of data, and then maybe when you query it, you can say, show me the data that's been vouched for by Safecast, or maybe vouched for by MIT, or Keio Daigaku, or one of those other organizations that helps collect these data as well. And then finally, I try to keep a curated set of a handful of help wanted issues. These sort of come and go. I think there's 9 there right now. But if you're not sure where to dig in, what I try to do is I pick things that we have in our issue tracker that don't require a lot of domain knowledge around Safecast to try to tackle, or your idea there. I talked about this a lot more in 2017, but I think it's important, since this is all volunteer, we're not paying people that work on this. It's important to have what people do be aligned with their interests. So if there's a feature that you really want to work on it. I think it would be really exciting to have contributions, beyond what we're imagining. And that is it. Thank you for listening, and I hope you consider taking part in the Safecast project. Safecast.org is our main homepage. You can get in touch with me. I'm at Matt Schaffer on Twitter or GitHub or pretty much anywhere else. And then matt@schaffer.me is my personal email. Feel free to reach out. I would love to talk about this sort of stuff. I'll stick around a little bit for questions, or should anyway. And yeah, have a great conference, and thanks for listening. Bye-bye, everybody.